Hello, everyone. In the preceding video, we introduced handling collision using the linear probe approach. One of the problems with linear probing is it has clusters. Sometimes the cluster can be very large. This will impact the performance. When you perform a search, you have to search all the elements in the cluster. This costs time. All these clusters, the elements in the clusters are sequentially allocated. We can try a different approach using quadratic probing. Linear probing looks at the consecutive cells beginning at index k. Quadratic probing increases the index by a quadratic value, 1, 2, 4. It's actually 1, 4, 8. So here for j is 2 is 1, and so this is for j is 1 is this is 1, and when this j is 2 is 2 is 4, and when j is 3 and 3 is 4 is 8. For example, for 26, so this is the mapping to index 4. It's occupied. Now we're going to increase the index plus 1, the next one. And it's occupied. And then we have this index plus 4. That is quadratic. Here is 8. It's k plus 4. So 4 plus 4 is 8. Let's look at this animation. I'm going to add 26 to this. And 26 is mapped to this 4 occupied, and then the next one, 16 is occupied, and then here is quadratic, is plus 4, and is going to be right here. So that's the location. All right, so let's delete 16. So 16 is deleted. Let's do a search for 26, and 26 is in the hash set. Let's search for 16. Search 16 is not in the hash set. Quadratic probing eliminated the cluster for which the elements are sequentially allocated, but it is invisible cluster still exists for this, all these elements, they're fixed pattern going to quadratic. So plus 1, plus 4, plus 8. So this is also still exists. So it actually did not solve this quadratic, the clustering problem. So what are we going to do? The next is to improve it and using double hashing. Double hashing uses a secondary hash function on the keys to determine the increments to avoid the clustering problem. So now here, look at 12. We're going to put 12 right here at this location 1, but it's already occupied. Now linear probing will search the next one, and quadratic also go to the next one, it's plus 1. But now what we're going to do is we're going to plus a value that is dependent on the key. So we're going to develop this secondary hashing function. This is 7 minus k remainder 7. That is 2. So this is 12, and k is 12, and 12 remainder 7 is 5. 7 minus 5 is 2. So here we are going to look at this 1 plus 2 is 3. And this is already occupied. And then we go to 2 times this h prime 12. and that is 4. So this is 1 plus 4 is 5. This is fine. So let's look at this animation. So let's put 26 right here. Insert. So we're going to put 26. This is going to be mapped to 4 initially. So this is 4 is already here. And so what is the secondary hashing function for 26? 26 remainder 7 is 2. So look, this is 5. So this is 5. 26 remainder 7 is 5. 7 minus 5 is 2. So that is 2. So we're going to back here now. This is going to be the next one you're going to look is 28. It's occupied. And then you're going to plus 2 times 2, h prime 26 is 2. So that is going to give you, that's 4. It's a 4 plus 4 is 8. So it's going to be put right here in the 8, right here. So now let's delete 26. Remove it. And let's check if 26 is we removed 16. So now this is 26. Check 26 is in the hash set. And let's check if 16 is in the hash set. 16 is not. So there's 3 approaches: linear probing, quadratic probing, double hashing. These are all called open addressing approach. So you find the available open space in the hash table to resolve this collision problem. Next, we will introduce a new approach. This is the handling collision using separate chaining. See you on the next video.